We're in section 4.7. And we're going to go into a little more detail about inverse trig functions. So let me grab a picture of just a regular sine function. Let me make it a little bigger. So this is a graph of y equals sine of x. Now when we've talked about inverse functions before, we had a way that we could tell if a function had an inverse function. Do you remember how we told from a graph how whether or not a function had an inverse function? It was the vertical or the horizontal line test. So it's one of those two. So for an inverse function, one tells us if we have a function, the other tells us if that function has an inverse function. Vertical line test tells us if our graph is a function. So is this graph a function? First off, does this graph represent a function? Does it pass a vertical line test? Yes. So the sine function, the cosine function looks the same. The tangent function has just a bunch of repeating kind of S shapes. So all of those are functions. We want to talk about the inverse functions. So we've eliminated the vertical line test, so what do we have to talk about? A horizontal line test. Does this graph pass a horizontal line test? So this does not pass a horizontal line test. But we've been using an inverse sine function. Our calculator has an inverse sine function. So we want to figure out a way that we can make an inverse sine function. So what we're going to do is for the sine function, I'm going to look from negative pi over 2 to positive pi over 2. And I'm going to just cut out, and I'm just going to highlight it here. I'm just going to cut out that section of the graph. So does this highlighted section from negative pi over 2 to pi over 2, does that highlighted section pass the horizontal line test? Yes, I can draw a horizontal line through those, and because I've cut it off here, I don't ever cross the graph twice. Between negative pi over 2 and pi over 2, does the sine function have all the values that it can possibly have? It starts here at negative 1, it goes through 0, and goes up here to positive 1. And on our unit circle, the sine function goes from 0 to 1 to 0 to negative 1, back to 0. So the sine function only goes between 0 and 1. So from negative pi over 2 to pi over 2, sine x does pass the horizontal line test. And I'm going to just say the H line test. And it takes on all of its possible values. So for x between negative pi over 2 and pi over 2, we can define an inverse function for y equals sine x. So if we restrict our domain of our sine function to negative pi over 2 to pi over 2, we can define an inverse sine function. And we say that our inverse sine function, equals the inverse sine of x We've used that before. And the other way you'll see that is y equals arc sine x. These two things mean exactly the same thing. A couple of important things about the inverse sine function. The important thing to remember about inverse functions. The inverse sine of a number is an angle. And the way we've defined our inverse sine function, our angle has to be between minus pi over 2 and pi over 2. So when we evaluate an inverse sine function, we're looking for an angle between minus pi over 2 and pi over 2. So let's look at a couple of examples of finding, and we're using our unit circle, we're finding exact values here for the inverse sine function. So let's look at a couple of examples. So we want to find the inverse sine of 1/2. So when we see a problem like this, what can help you think about this is we can say what this question is asking is what angle between minus pi over 2 and pi over 2 has a sine of 1/2. So this is a unit circle problem. So let me look at my unit circle. What I'm looking for is what angle has a sine of 1/2. Sine is our y component. So where on the unit circle is the sine 1/2? 30 degrees or pi over 6. So the inverse sine of 1/2 is pi over 6 or 30 degrees. Yes. So this is 30 degrees or pi, not pi over 2, pi over 6. And one thing that I want to remind you about on the unit circle, negative pi over 2 means we're going counterclockwise. So we're going counterclockwise down this way. We're not going all the way around, we're going clockwise down this way. We're not going counterclockwise around this way, we're going down this way. So if we're looking at an angle down here in the fourth quadrant, we wouldn't be looking at 11 pi over 6. We'd be looking at negative pi over 6. This angle would be negative pi over 4. This angle would be negative pi over 3. And this angle would be negative pi over 2. So when we're talking about the negative angles, we're going clockwise this way. So that's another important thing to remember. All right. So now let me ask another question just to try to be tricky here. What is the sine of negative 1? Let's look at our unit circle. What's that? Not sine. I wanted to do inverse sine. Inverse sine of negative 1. So what angle between negative pi over 2 and pi over 2 has a sine of negative 1? It would be negative pi over 2. So I look at my unit circle. The y value is -1 down here, and this is negative pi over 2. The other way we could write this is or negative 90 degrees. So when I see this problem, I'm saying what angle between negative pi over 2 and pi over 2 has a sine of whatever. That's what the inverse sine is asking us. Questions on inverse sine and what is telling us. All right, let's quickly look at the cosine function. So here is a cosine function. Let me grab that. So we're going to do a similar thing with the cosine function. We can see right away that this does not pass the horizontal line test. For the cosine function, I'm going to restrict my domain here. If I restrict the domain of the cosine function, then it does pass the horizontal line test, and the cosine function has an inverse. So for cosine, for y equals cosine x, we restrict the domain. So between 0 and pi, and then we can define an inverse function. In between 0 and pi, cosine takes on all its values between +1 and -1. So we can define an inverse function. And we say that y equals the inverse cosine of x. And the way we can think about this is an angle y is an angle between 0 and pi. So very similar to what we did with the sine function, we can do with the cosine function. Right, or I can say or arc cosine x. Arc sine, arc cosine, arc tangent are the same thing as inverse sine, inverse cosine, inverse tangent. So for the cosine of a number, we get an angle back that's between 0 and pi because of how we restrict our domain to get our inverse function. Same idea. The inverse cosine or the arc cosine is an angle. So let's look at a couple of examples of this. So if we wanted the inverse cosine of square root of 3 over 2, what this question is asking us is what angle between 0 and pi has a cosine of square root of 3 over 2. So this is a unit circle question. So I go to my unit circle, and my cosine of my angle on the unit circle is the x-coordinate. So I say what angle has an x-coordinate on the unit circle of square root of 3 over 2? Pi over 6, or 30 degrees. And for the inverse cosine, I'm looking between 0 and pi. So for the inverse cosine, I'm only looking at angles up here in this top half of the unit circle. So my answer here is going to be, if I go back to my problem, what angle has a cosine of square root of 3 over 2? It's pi over 6 or 30 degrees. So that's how we find inverse cosines. We're looking for an angle, and our angle has to be between certain parts of the unit circle. We can do a similar thing for inverse tangents. We know that our inverse tangent, or our tangent function, if we have y equals tangent x, I'm just going to sketch out a quick sketch. We know that our graph looks something like this, and we have all of these asymptotes, and my tangent function repeats like so. And this is y and this is x. So just by itself, my tangent function is not going to pass the horizontal line test. So what we do is we restrict the domain to just the section between minus pi over 2 and pi over 2, just like we did for the inverse sine. So for y equals tangent x, we restrict x to minus pi over 2 to pi over 2, and we can define an inverse function. The tangent takes on all of its values between negative pi over 2 and pi over 2, and it passes the horizontal line test, and we can write y equals the inverse tangent of x, or y equals the arctangent of x. And when we are looking at an arctangent or an inverse tangent function, what we're looking for is an angle between negative pi over 2 and pi over 2. Same idea as the inverse sine, the inverse cosine. So let me write a quick summary of the inverse trig functions. So our summary. Y equals the inverse sine of x. This is the same as saying the sine of y equals x. Our domain of the inverse sine function negative 1 is less than or equal to x less than or equal to 1, and the range is minus pi over 2 less than or equal to y less than or equal to pi over 2. Y equals the inverse cosine of x is the same thing as saying that the cosine of y equals x, and our domain is minus 1 less than or equal to x less than or equal to 1. I can only take the sine or cosine, the inverse sine or cosine of something between 0 and 1. And the range for the inverse cosine is 0 less than or equal to y less than or equal to pi. My angle is between 0 and pi. And y equals inverse tangent of x means the same thing as the tangent of y equals x. Our domain for the inverse tangent function is all real numbers. And our range is negative pi over 2 less than or equal to y less than or equal to pi over 2. So my angle for the inverse tangent is always between negative pi over 2 and pi over 2. All right, couple of things that we have to do, that we have to look at, and then we'll be done for today. Well, actually, it's one other topic. We're looking at compositions. So one important thing about compositions of functions and their inverses is that a function and its inverse basically undoes each other. And that's true for inverse sine, sine and inverse sine, cosine and inverse cosine, tangent and inverse tangent. But we have to make sure that we're following our domain restrictions. So I'm going to say that the sine of the inverse sine of x equals x, and the inverse sine of the sine of y equals y. And I'm going to say the same thing for the cosine. And the same thing for the tangent. These are all true as long as we pay attention to our domain restrictions. So we have to pay attention to our domain restrictions. And let me show you a couple of examples of what I mean here. So what we're saying is that the function and the inverse function undo each other as long as we're in those domain restrictions. Remember, we restricted the domain of the inverse sine, inverse cosine, and inverse tangent. So if we had something like the inverse tangent of the tangent of 5 pi over 6. So let's do this inside out. So we're going to say this is the inverse tangent. And we need to look at our unit circle, and let's figure out what the tangent of 5 pi over 6 is. So let's go pi over 6. Here we are at 5 pi over 6. The tangent of 5 pi over 6 is negative square root of 3 over 2. Sorry, sine over cosine 1/2 over the negative square root of 3 over 2. So the tangent of 5 pi over 6 is 1/2 over negative square root of 3 over 2, which turns out to be the inverse tangent of negative square root of 3 over 3. So we're looking for the inverse tangent of negative square root of 3 over 3, but when we look for our inverse tangent, our angle has to be between negative pi over 2 and pi over 2. So let's look at our unit circle. What angle is going to have a tangent of negative square root of 3 over 3 that's between pi over 2 and negative pi over 2? We're only looking over here. Anybody have an idea? Right here, my tangent is minus 1/2 divided by square root of 3 over 2, which is minus square root of 3 over 3. So my inverse tangent of negative square root of 3 over 3 is negative pi over 6. So 5 pi over 6, I can't say that the inverse tangent of the tangent of 5 pi over 6 is 5 pi over 6 because that is outside of my domain restriction. So when my angle turns out to be outside the domain restriction, I have to look for an angle inside my allowed domain. So for the sine, for the tangent, my allowed domain is negative pi over 2 to pi over 2. If my angle is inside my allowed domain, then the tangent and inverse tangent undo each other. But if it's outside, I have to make sure I find the angle that's in my restricted domain. And I think once you practice with this a little bit, it'll start making a little more sense. But we have to make sure that our angles are inside our domain restrictions for this. All right, let me look at one more example and then we're done. Let's look for the cosine. Yes. We have to find an angle. So what we did back here is we have to find an angle inside my domain restriction that has a tangent of negative square root of 3 over 3. So I have to find an angle that's inside my domain restriction that has the same tangent as 5 pi over 6. So I only look for the tangent, I only look between pi over 2 and negative pi over 2. And I have to find an angle that has the same tangent as 5 pi over 6. What's that? By knowing that the tangent is the sine over the cosine. And you have to find an angle in this quadrant, in this half of the circle, where the sine over the cosine is negative 1/2 divided by the square root of 3 over 2. It has to be the same as this. All right, so let's look at the cosine of the inverse sine of 3/5. Let's see, what time this class ends? 1:30. Actually, I am going to, we'll take this one up. We'll finish up with this tomorrow. I'm going to stop for now, and let me amend the homework.